Okay, hi everybody. And so we will be recording this part of the session. If anybody has any objection with recording, please say so now. 5, 4, 3, 2, 1, boom. Okay, so I'm gonna share my screen. And so I asked you guys to work on these problems. So the idea is for you to practice some of the things that we've been working on that have to do with, well, functions, the definition of functions, and the sketching of functions according to the different types of shifts, reflections, et cetera, that can occur. And while we're doing that, we're actually also practicing the previous topics that have to do with domains and restrictions and et cetera. And so there's a couple of sets of problems. It's 10 problems here. We're going to start off with this first set of problems that we have here. So what I'm going to do is that I'm going to the idea is for you guys to have tried to solve them in the previous hour. So what I'm going to do now is I'm going to go through them and I'm going to do them here. And please compare with what you did and ask questions, okay, if you haven't. So I'm going to jump over here to the canvas over here. And you can see can you see the black canvas right now?
Yes.
Okay, perfect. Thank you so much. Okay, so what I will be doing now is that I'm going to be going through each of these exercises, okay? And let's start with the first one. So the first exercise, which is exercise A, says that f of x, and please correct me if I write down anything incorrectly, f of x equals x minus 2, right? So when we're going to be doing the sketching of a function based on what we are provided, there's a couple of things to remember. First, we have to remember what the base function or the base model for the function is. This means assuming that we have no reflections, no shifts, nothing like that, how would the function look? And so remember that we're talking about power functions. So at some point in your in the PowerPoint for Unit 2, there's a slide that has all of the different models for the function. For the functions. I believe it is, Andrea, can you help me out? What slide number is that? 25?
25.
25.
Yes.
Thank you very much, Andrea. So the reference is slide 25. So if we look at the function, then we got to go see slide 25 and kind of look at the model or the base function for that. That's one thing. And the other, remember that we're doing a sketch, okay? We're not doing the precise graph and we're not doing a plot. What does this mean? This means that it's a rough approximation of how it will look like. It's not precise. It should just give us an idea of how the function would look like if we were to graph it. So this is just a very general reference as to how it looks like. So we're not being completely precise. We just want to know the way it looks. So first off, we need to see what is the base function that we're talking about. So this is a power function. The x is elevated to the power of 1. And we know that if a function is elevated to the power of 1, and this is actually the next topic that we're going to be seeing in the next section of the unit, this is going to be a line. Okay? Is that clear to everybody? That's the base function. The base function is a line. Okay? And so after we identify the base function, now we need to know what's happening with the base function according to whatever is around the base function, okay? And so in the function that we're given, which is f of x equals x minus 2, what is happening? Can somebody tell me what is happening to the base function?
It's shifting down 2 units.
Perfect, correct, Andrea, perfect. So we know that this is a vertical shift, okay? We know that this is a vertical shift, and we know it's a vertical shift because of this component here that's being, in this case, subtracted to the function. This is going to generate a shift that's vertical, and actually it's going to be a shift down, okay? And so how many units? 2 units, the amount of units that are seen there. And so the new function is actually going to be, if we consider this is -1, this is -2, then the new function is going to go something like this. It's going to be down 2 units, okay? Now notice something here. Do you notice that there's an intersection here? So eventually it crosses the x, axis. We don't know where that intersection is. So if right now, if in the exam you just give me this, it's fine because it's a sketch. We don't exactly know where it's crossing, okay? We don't know when that intersection is, okay? We could find it, by the way. How could we find it? We could make the function equal to 0 and find the value of x, and actually we would find that this intersection here occurs in x equals 2. But again, we're not being asked for that, okay? In the solution to the problem, they're just asking us to sketch, okay? And so this could be the solution for this problem, okay? Okay. Now, it also says for us to identify if the function is if it's odd, even, or neither. Okay. Remember, there's many ways to do this. There's actually, we can do it 3 different ways. One is substituting -x into the function and seeing what happens. The other is grabbing a number, any number that's in the domain, and substituting the positive and the negative and seeing what happens. And what could be a third way of kind of identifying if it's odd or even? Can somebody tell me?
By looking to the graph?
Correct.
Or to the sketch?
Correct. Very, very good. Very, very good, Estrella. Because an even and an odd functions are going to have symmetry. An even function is going to have symmetry with regards to the y-axis, and an odd function is going to have symmetry with regards to the origin. So if we look at the graph, we can clearly see if it's even, odd, or neither. If we look at this graph, the result, the one that's in green, we clearly can see that there is no sort of symmetry either with the y-axis or with the origin. However, let's demonstrate that. Let's demonstrate that. So if we wanted to demonstrate that, let's choose a number. I'm going to choose x equals 1 and x equals -1. And so I'm going to say, let's see what happens first with the x equals 1. We are going to say that f of 1 is equal to, and we're just doing this to practice, 1 minus 2, and this is going to be equal to -1, right? And then let's say now that x equals the negative version, which is -1. And if I substitute -1, f of -1 equals -1 minus 2 equals -3. And so what do we see there? We see that they are different, okay? These two are different, okay? Well, let's use mathematical notation. They are different. And since they are different, then this is neither even nor odd. Okay? Neither. Okay? Questions with this one before we move on to the next ones? Is this one clear? Did you guys get the same thing? This was a relatively easy one. Nope. Okay.
Yes.
Okay, I'm gonna move on to the next. The idea is for us to cover either today or on Wednesday all of these exercises. Remember, you've got homework tasks 6, I think. 6, yeah, I think it's 6 to be delivered.
It's 5.
5? 5. Homework tasks 5 for delivery on Wednesday. Okay. Okay, so I'm going to clear this and let's go on to the next one. Okay, on the next one, we have, the next one is B. We've got f of x equals x minus 1 to the square plus 5. Is that correct?
Yes.
Okay.
Yes.
Good, thank you. So we've got x minus 1 to the square plus 5. So the first thing we need to do is identify the base function, okay? So I hope it's clear to everybody that in this case, the base function is a parabola, okay? So how do we know that's the base function? Again, because we're working with power functions. So we look at wherever the x is, sorry, wherever the x is, we see normal cough, not COVID. We see to what power it's elevated. So this would be elevated to the power of 2, and so that means it's a parabola. So the base function would be a parabola. A parabola that's centered in the origin. By the way, this is, I mean, we haven't explicitly mentioned this, but all of the base functions are centered, or the reference is the origin. That's why when we add or subtract things or multiply by minus or by a factor, that's why that changes. It either compresses, stretches, it reflects, or it shifts. So the base functions are always going to be referenced with regards to the origin. Okay, so now let's see what's happening here with this function. And by the way, remember one thing. There's going to be reflections. There's going to be shifts. I'm going to solve it a certain way here, doing certain steps. But remember, the order of the steps doesn't really matter. You should get the same thing. So maybe you first do the vertical shift and then you do the horizontal shift. If I do first the horizontal shift and then the vertical shift, we should get the same thing, okay? So the order in which you do all of the shifts, reflections, or compressions or stretches doesn't matter, okay? So the first thing I'm going to do, and again, I'm going to try to use some color coding here to try to explain, is that I'm going to look at what is in here. I'm going to look at this part here first. So what do we see there? What type of operation are we doing with the function with what we have there inside the power function? Remember that inside means that if the reference is x to the square, then whatever is inside the power, that's what we're looking at. So what will we have there?
It will be to the right.
It's a shift, correct? Thank you very much, Estrella. It's a shift to the right. Okay.
Okay, shift to the right.
It's correct. So it's a shift to the right. Okay. How do we know it's to the right? Whenever we have a negative number, it's to the right. Whenever we have a positive number, it's to the left when it's inside. And so that means that we're going to have a shift to the right. Very, very good. Like Estrella said, 1 unit. It's going to be shifted to the right 1 unit. So I'm going to be doing this step by step. So first it's shifted to the right. And so we're going to have something like this. I don't like the way that looked. Again, this is a sketch, so I really don't know where it crosses here in the explain. I'm going to exaggerate this a bit just so we don't really know where it crosses in the y plane, but since it's a sketch and I'm not asking for it, If I were to ask you for the intercepts, then you would need to give me those values, but I'm not. So that would be the shift to the right, like Estrella correctly indicated, a shift to the right 1 unit. So this means it would be a shift to the right. Okay? Questions there? Are we okay up to this point?
Yes.
Yes.
And now let's see what else is happening. So now we've got another section here that's this +5 that we've got here. And so what does this +5 generate?
It shifts 5 units up.
Correct. Very good, Andrea. It's a +5 and it's outside the power function. So that means it's shifting 5 units up. Okay. And so that gives us a new reference point. And why am I marking the new reference point? That new reference point is now substituting or is now being equivalent to what originally was the origin. Okay. So that means that now my new function is going to be something like this. Okay. So the parabola was shifted to the right 1 unit and it shifted up 5 units. Okay. Is that function even or odd?
Neither.
Neither. Correct, Andrea. Why? Because there's obviously no symmetry. We can, I'm just going to do it so we can practice. I'm going to select x equals 1. So f of 1, and 1, I can do that because that's part of the domain. This would be 1 minus 1 elevated to the square plus 5. This would be equal to this would be equal to 5. And if I substitute x equals -1, then f of -1 would be -1 minus 1 to the square plus 5. -1 minus 1 is -2 to the square is 4 plus 5 is 9. So we could clearly see it in the graph that these are different, and so it's neither. Okay. So questions with the second problem?
No.
Are we okay up to this point? Good. Now let's go to the next one where we're starting to add a few other things there. Okay. So if there aren't any questions, I'm going to move on. Please, double, triple, quadruple, please. If I ask and you guys have a question, please ask it. When I say I'm going to move on and I'm going to clear the screen, I can't go back to whatever I'm showing. So please remember to ask any questions before we move on to the next one, or else whatever I put on the screen is going to be erased. Okay. Remember that this, if everything goes well, this is going to be recorded and I'm going to upload it to Blackboard. But I'm also going to let you take screenshots or whatever you want to take. So I'm going to move on to the next one if there aren't any questions. So 1, 2, 3. Okay. Let's go on to the next one. Now we're adding a few other fun things here. Let's see, f of x is equal to, this is minus 2x to the 3, minus 3, is that correct?
Yes.
Yes.
Okay, perfect, thank you. And so again, I'm hoping you guys are looking at your slide number 25, I think, and looking at the base function. So the base function has to do with the power here. which in this case is a 3. And so the base function is going to look something like this. Okay, it's going to look something like that.
Professor, how are we going to know which is the base function?
Okay, so Viviana, this is important. So first off, we're talking about, and please turn on your cameras when you participate. Okay, please. So Viviana, first off, remember that the topic we're covering right now is power functions. Okay, so a power function is that I'm going to have something. It's going to be a function that's elevated to a power, and remember that elevated to a power means that the wherever the x is elevated to an integer. Okay, I'm sorry, it's elevated to a real number. It's not necessarily can be an integer. So it's elevated to the 1, 2, 3, 4, 5, 6, etc. It could also be elevated to a fraction, 1/2, 2/3, etc. Okay, are we okay up to that point? Okay, so we're going to look at the function again. So right now this function is elevated to what power?
3.
3. And so I'm going to do a switch over here just to reference and what I'm talking to with Viviana. Give me a moment. And if you go, I mean, the idea is for you guys not to memorize these, but not to always have to look at the slide. But if you go to slide number 25 in the PowerPoint, Viviana. Okay. Do you see that one, Viviana? That's
What am I seeing?
Let me change the screen here. There you go. Do you see
Yes.
that, Viviana?
Yes.
This is slide number 25 in the PowerPoints that represents each of the graphs for each of the types of power functions. Okay. And so if you look at these, which one? Which one, if we're talking about x to the 3, something where x is elevated to the 3, or wherever x is, it's elevated to the 3rd power, which graph would it correspond to?
C.
Correct, it's C. See? So for example, if I were to give you a square root where the x had a square root, which one would it correspond to?
To a square root. B.
No, square root, not elevated to the 2.
Ah, okay.
Huh?
Square root.
Square root is elevated to the 1/2.
Oh, G.
G, correct. And if the x were in the denominator?
It's E.
Or F, depending on
E
if
or
it's,
F, yes.
and remember that when the x is in the denominator, it means that the power is negative. So 1 divided by x is the same to x elevated to the -1. 1 divided by x squared is the same as x to the -2. So we're still talking about power functions, but whenever the function is in the denominator, the
Our function is negative.
negative, correct.
Yes.
Did that answer your question, Viviana?
Yes.
Now,
Thank you.
the idea, again, I don't want you guys to memorize things. I'm telling you to reference slide 25 because the models are there. If I give you an y equals x, you should know it's a line. If I say x to the square, you should know it's a parabola. If it's an x to the 4, it should also be a parabola. So this is just a reference for you guys to practice. In the homework tests and in the exercises, you should be looking at this reference to see what function we're talking about. Okay.
Teacher, I have a question.
Yes, go ahead, Yusuf.
For example, if it's negative, it's always gonna be like the opposite line or graph, or I don't know, like, can I write on the board?
Sure.
And
Let me just to keep things ordered. So Viviana, is this clear? So I can switch to the.
I know I was gonna ask from here.
Okay, if you want to write there, go ahead, Yusuf.
Yes. For example, if this is negative, it's gonna be like this or like this and like that.
Yes, it's yes, Yusel. However, when we say it's negative, it means the whole function is negative.
Yes.
So That is correct. So for example, you have f of, leave the other drawing there, Viviana. I'm sorry, Yesel, leave the other drawing there. Yeah, thank you very much. So for example, Yesel, we have f of x equals x to the 3, that's the blue one, okay? But if we say f of x equals minus x to the 3, okay, that's the red one you just drew, okay? And if in this one, we've got f of x is 1 divided by x, then the red one, which is the one you drew, would be f of x divided by, I'm sorry, f of x is equal to 1 to minus 1 divided by x. Okay. There's something very particular. Notice this, because you can either get extremely confused or not. There's something extremely particular for these two graphs that you chose. Yes, sir. Okay. And again, I'm gonna when we move forward and I teach this class again, I'm gonna go to you to ask for you to design questions in the exams, because you think about things that are oddly interesting. There's something very, very particular for these two graphs that you showed. Remember that we're talking about reflections. So if it's a negative like you're showing there, it's a reflection on the y-axis. You notice that? But there's something very particular for these two examples that you just showed. The reflection on the y-axis is exactly the same as the reflection on the x-axis. But that's something very particular for these odd functions that we're showing here, okay? But yes, the negative is going to, and why is that? Why do we do that? Or why does the negative change these? Because the negative, anything that's positive is now going to turn negative, and anything that's negative is going to turn positive now. That's why the reflection occurs, okay? So is this clear, Yesel? Does this answer your question?
Yes, thank you, teacher.
Okay. I'm going to ask you to design the next exam. So ask Yesel. Okay, any other questions before I move on with the problem? These are very good questions. Thank you very much, Viviana and Yesel. Questions? Nope. Okay, okay. Let me go over here. I had to clear, yeah, so everything was cleared. So I'm going to go back and do it again. So we were in C, right? C is f of x. Oops. I have to draw this again. F of x equals minus 2x to the 3 minus 3. And the base function then is going to be x to the 3.
Teacher,
Yes.
I think the
Oh, I didn't
page-
switch?
Yes.
Okay. Thank you very much, Viviana. Remember to tell me that before I'm half hour into the problem. So thank you very much, Viviana. Let me just switch over here. There we go. Are you now seeing the
Black screen.
That's what you should be seeing. Perfect. Thank you very
Yes.
much, Viviana. That's interesting. So if I share again, that's what happened before. If I share again using the new share function of Blackboard of Zoom, then everything gets erased. So here we go again. And thank you, Viviana, for that. F of x is going to be equal to minus 2x squared. x3, I'm sorry, minus 3. And so in this case, the base function, if we look at, or the model for the function we're talking about, we are looking at the power of the function, which is this 3 that we have here. And remember, I'm using color coding. And so it's going to be something like this, okay? That's the base function. Now let's look at what's happening. And remember, we can do this in any order we want. Okay, I'm going to be doing it in a certain order, but we should get the same thing if we do it in different orders. Okay, so I am going to do the following. Let me draw this again. And remember, I'm using some color coding here to try to represent what's happening. So the first thing I'm going to do is that I'm going to look at this 2 that's here. what does the 2 do to the function? If I have something multiplying the function,
Is stretching the function.
it's a stretch of a function. Why is it a stretch, or how do we know it's a stretch and not a compression, Andrea?
Because
Remember to please turn on your cameras. I like to see you guys participate. So I'm sorry. Go ahead, Andrea. How do we know it's a stretch and not a compression? Do you remember?
because it was bigger than 1.
Correct. So if it's a 2, 3, 4, 10, 10.5, 200.6, it's a stretch. If it were 0.5, 1/4, 1/10, if it's a number between 0 and 1, it's a compression. So it's a stretch. Now, by the way, you guys, don't get extremely stressed about the stretching and compressing. It's because we're doing sketches. Okay, so it's just a reflection of what's happening. So I'm just going to do this to kind of explain. This is the original function. I'm exaggerating. The blue is the original function. Remember that. So the multiplied by 2, which is a stretch, is the only thing that's going to mean it's going to pull. And so this is going to be a little bit more like this. It's going to be a bit thinner.
Professor,
Okay? Yes, go ahead, Andrea.
I have a question. Is by 2 or by -2 when we multiply?
I'm just, notice where I put the pink thing. I'm just looking at the 2 right now. I haven't looked at the minus yet.
Yes, but when we stretch it, because we need to multiply it by the y.
I'm doing it step by step, Andrea. I'm just looking at the 2 right now, and then I'm going to multiply it by the minus.
Okay. Thank you.
Okay, so right now I'm trying to do it step by step. Okay, so the first is the stretch. We have to understand that the stretch is happening. That's the pink. I'm not looking at the minus yet. Okay, and so we're doing a stretch. That only means that it gets a bit closer to the y-axis. It gets stretched. Now we're going to look at the minus. Okay. And so the minus is going to be what? It's going to be a reflection. Okay. That's what Andrea was talking about. It's going to be a reflection, and it's going to be a reflection that's going to flip the graph. And so what we're going to have now is the following. I'm going to draw it here on the same one. Okay. So now we're going to reflect it, and the reflection is going to be this one here. Okay. So Andrea, the purple one is the blue one is the original one. The pink one is multiplied by 2. The purple one is multiplied, or the violet one is multiplied by -2. Okay. Is that clear, Andrea?
Yes, thank you.
Okay. Questions up to this point before we go to the next one, or the next step?
No.
And so what's the next thing that we have there? We've got the -3. Okay. And the -3, what is that going to do?
We need to shift to down.
Correct. Very,
3 units. I'm sorry.
correct. Perfect. Perfect, Estrella. Correct. This is going to be a shift downwards. And like Estrella mentioned correctly, this is going to be -3 units. So this means that the new function is going to be over here in -3. And it is going to be something like this. Okay. So that would be the complete representation of that one. Is it clear that we don't have symmetry? Meaning that it's neither even nor odd?
Yes.
Okay. Questions with this one before we go on to the next one? Okay.
No.
Okie dokie. So I'm going to clear this one in 3, 2, 1. Boom. Okay. Now let's go to D. D, we have f of x equals 2 minus 1 divided by x plus 6. Okay. And so the first thing we need to do is to identify the base function that we're talking about with this one. And so the first thing that we need to notice here to identify the base function is that we've got here the x is in the denominator. Okay, it's in the denominator. And so if the x is in the denominator, then the power that we're elevating the power function to is equal to -1. Okay, so these are still power functions. Remember that a power function is something that has an x elevated to a certain power. Okay, so this is still a power function, but the power that we're elevating it to is -1. And so because it's in the denominator. And so the base function for this one, if you look at slide 25, is going to be something like this. And the important thing here is that for this function, for the original one, which is 1 divided by x, the x and the y-axis are asymptotes. Okay, that means they're never touching. Okay, so is that clear that that's the base function?
Teacher,
Yes, go ahead, please.
what did you say about the -1? I
Okay, so remember that we're talking about power functions. So a power function is, let me draw that with a different color just not to confuse. Let's use this one. So a power function is a function where we've got, in this case, an x, or something that has an x, elevated to a power. That's what a power function is. So we're just talking about power functions. So what happens if n is equal to -1? What type of function do we have? X to the -1. And what does a negative power mean? It means, or what is a negative power? What does that mean? It means that the x is in the denominator. So it's still a power function, but whenever we have a negative power, it means that the function is in the denominator. Okay. So in this case, since we've got the x plus 6 in the denominator, remember that this is equal, this part here, just the orange one, okay, is the same as having just the orange one, okay? That is equivalent to having x plus 6 to the -1. Okay, is that clear, Lisa?
Yes, thank you.
Good. So that's why it's a power function, and that's why we take that base model. Okay. And now we are going to be having some shifts here. Now, the first shift that we're going to identify, or that I'm going to identify here, is that we've got a 6 here, a +6. What type of shift is that going to generate? Can somebody tell me?
Is shift 6 units up?
Nope.
To the left?
To the left. Remember, and this is where I'm noticing some of you are getting stuck. Where is the 6? The 6 is inside the power function. Okay, you notice that it's inside the power function. So if it's inside the power function, remember that whenever it's inside the power, that means that the shifts are to the left or to the right. Whatever is outside of the power or the power function, that's when we go up or down. So in this case, the +6 is going to be a shift to the left, okay? So in this case, we're going to have first off a -6 here. And so whenever we're dealing with these sorts of functions, it's important because we've got an asymptote to kind of identify the new reference. And so the shift is now going to generate that the new function is going to be moved 6 units to the left, okay? And again, that's because it's inside the power function, okay? Questions there before we move on to the next thing we need to notice there?
Me.
Go ahead, Alejandra.
So that means that it's never gonna touch 6.
Correct. That's a very important observation, Alejandra. Very important observation. The original function, the asymptotes were the x and the y-axis. So that means it's never going to touch the y, and it's never going to touch the x. The shift generates, the horizontal shift, it's equivalent to moving the y-axis. So now the new asymptote, instead of being the y-axis, is going to be 6. That's why I'm marking it with dots. It's never going to touch 6. That's a very good observation. And it's correct, Alejandro. Very good.
Thank you.
Now, the next thing I'm going to do here is that I am going to, I'm actually going to do it here. I'm going to look at this negative here. What is this negative going to create? This negative is going to create a reflection. Okay. The pink generated a shift. The negative is going to generate a reflection. Okay. So what's going to happen with the reflection is that now, and this is going to be the purple one, now what we're going to have is this here. And we're going to have this, this over here. Okay. So the pink is the +6, it's been moved. The minus generates the reflection. Okay. And lastly, what do we have here? We've got a 2. What does that 2 generate?
Shift up 2 units.
Correct. Very, very good, Andrea. So it's going to be a shift. We know it's a shift up in this case because it's outside of the function. It's outside of the function and it is positive. That's why we know that the shift is up. So it's going to be, I'm going to mark it here, 2 units up. And I'm also going to mark this here the same way we did it there. And I'm going to mention why I'm marking this, referencing what Alejandra mentioned. And so now we've got the 6 there, which we already had, and then we've got now a 2 here. And so the shift or the shift with the 6 generated a new asymptote. That was in this case the new y-axis. And the shift up with the 2 is now going to generate a new asymptote. That's going to be the 2. And so the new function would be something like this. Okay. So now the function is shifted. First, we identified that it was shifted 6 units. Then we saw that it was negative. And then it's shifted up 2 units. And so the green one would be the complete function that includes all of the movements.
Professor, I have a question.
Yes, go ahead, Andrea.
On the part of the reflection, there you said that the reflection was on the x-axis or y-axis.
Actually, it's in the x-axis. But again, for this particular model, for this particular function, the reflection on the y-axis looks exactly the same as the reflection on the reflection on the x-axis looks exactly the same as the reflection on the y-axis. If you notice.
But it's in the x, right?
It's in the x, yeah. So notice, Andrea, that this pink part on the bottom now went up, and this pink part on the top now went down. But it's exactly the same as if they would have gone the other side. But this is something very particular for these types of functions. The x and the y reflections are going to look exactly the same. Okay, but what we're applying here, since it's outside, it's a reflection of the. To be strict, it's a reflection on the x-axis.
Okay.
I'm just going to mark it here, just so we're clear. It's a reflection on the x-axis. Okay. Okay. So we're going to stop it here. I'm going to upload this video to Blackboard in a few minutes. It's going to be there so you can review it, and we will continue with the problems on Wednesday. Okay. If you have any questions regarding these problems, we're going to do them all. Don't worry. Or the homework task, please let me know. Okay. And I'll see you guys on Wednesday.